You see my screen? Yes. Okay, great. Yeah, I would like to present you the Nakolos core and where we are. As you know, we have been done or are doing also something for 5G-MAG reference tools a lot. So we got a lot of, let's say, inspiration and a lot of knowledge also from this work. And today I would like to present you the Nakolos core, which was basically based on all this knowledge. So a short introduction, core overview, web user interface, features, and then trials for 5G-MAG members. So just for an overall understanding, Nakolos is an end-to-end integrator for broadcasters, network operators. There are two things we provide. One is the Nakolos core I'm talking about, and the Nakolos middleware. Just as a reminder for those who are not so in 5G broadcast and the 5G broadcast core. So typically we have kind of TV input, audiovisual input. We probably also have emergency warning input from the government. Then there are some transmitters out there, typically our TV transmitters, clustered maybe in some reception areas, SFNs or something like that. And for 5G broadcast, there is a central management entity needed, which is the 5G broadcast core, which is here marked in red. And following 3GP interfaces and entities, you typically have a BMSC, a broadcast multicast service center, an MBMS gateway, and an MCE. And in case you would like to do emergency warning, you also need something with CVC and an MME. And then, of course, there are a lot of interfaces. For the BMSC, you typically have an XMP interface, which provides you a REST API that you can provision services. There are also part of the XMP is basically the input for the MBMS gateway. And then you have the other interfaces, the M1 interface from the MBMS gateway towards the transmitters. And there's an M3 interface and an M2 interface also facing the transmitters. And for the emergency warning, you have on the input at the CAP interface and the S1 interface between the MMA and the transmitter. Just saying that we're using that also in Austria in our test bed and also for our productive core. And it's also deeply integrated already. So how does it look like? So from the architectural perspective, we are working with a virtualized platform with Kubernetes. So the idea is you can install the core on premise and in the cloud. So we also run it in AWS at the moment and have connections to transmitters which are on site. So this also allows scalability and flexibility, of course. So and all the components are or all the entities are virtualized basically separately. I will come to that in a minute. And our focus for this core was basically, as we want to use it for our own productive environment, it should be easy to install. So it's basically an image you have, and you can set it up on Ubuntu. So we're running it actually also on Ubuntu server. You can also install it on any other environment as long as you can have the virtualization layer in between. And it should be, and that's one of the most important things for us, easy to operate. So we faced during our last years with 5G broadcast the issue that our operation teams, they are not really familiar with 3GPP. And it turned out they probably are not willing to have next to satellite, terrestrial streaming. They're not willing to, let's say, dig very deep into 3GPP terminologies. So it was in the focus to have an easy web user interface. So how does it look like? There is a Kubernetes cluster, then there is a kind of a control, let's say, entity or a pod, and then you have a BMSC, an MCE, and then for the ingress, you have for each service a own MBMS gateway. And depending on the input, it's a multicast ingress or it's a flute encoder and so on. So that's the high-level architecture, I would say. And there's also for the user interface our own pod. Okay, so coming to the web user interface, so we try to split it for operators and experts. So operators are those colleagues who are not happy to get very deep into 3GPP terminologies. And the question was, what do they really need to do? So there are just three things, I would say, or four things. One is they want to have an overview. And then they want to have ideally just lights green and red or maybe yellow. And if everything is green, then of course it's nice. If it's not green, then they should probably look into logs. So they can look into logs. And then what they typically do is they need to add or delete or edit inputs. And at some point, if there are new transmitters or changes in the transmitters, colleagues will phone them, and then they need to add or delete or change the transmitter and connect them to the core. And then the second role we have here are experts, and the experts are those people in our organization who really are familiar with 3GPP parameters, and they should be capable of dealing with all the settings you can do. So these are there who do the core settings, so they can configure the main parameters, but also reception settings. So that's basically the idea we were following here. We also have two, let's say, two different names for traditional things. So we have something we call reception condition that links basically to the service class ID of 3GP. And we use it as a label for a non-3GP term for the operating team. I will show you that in a minute how it works, but you see already there is a label which is readable, let's say, we call like stationary outdoor, mobile outdoor, until 60 kilometers per hour with a description. And this is linked to the service class ID, which is used internally of the core. And then there are reception areas. We see reception areas like a multiplex in DVB-T2, which is of course simplified, but that's a bit the idea. Internally, we link it to MBSFN areas, and you can add transmitters to these reception areas, and you can configure then also the bandwidth. So if you have, for example, this 8 megahertz bandwidth, you can set up different PMCHs with MCS and so on. So here you see a screenshot, an example one where we have a reception area in Berlin and one in Munich. And how you can also configure the capacity in Berlin. So you have different reception conditions here. For example, stationary outdoor, which is this one, mobile outdoor and mobile car, which we labeled. So behind the scenes, the system is mapping that up for the experts, but for the operation team, they only know, okay, we have something here in Berlin, and if I want to add a service to customers who should receive it stationary outdoor, they just click stationary outdoor, so they don't need to know anything about MBSFN areas, service class IDs, and so on. And then the third thing we tried to think about is how to add transmitters to areas. And we came up with a solution that typically what you need to do is, if you have a new transmitter, you set it up and you need to tell the transmitter the IP of the MCE. So we add the MCE IP to the transmitter, and then the transmitter uses the M2 protocol typically to connect to the MCE with M2 setup messages. And in order to avoid that people accidentally in our, let's say, outdoor operation team add just transmitters and they are then somehow in the core, we are not allowing them, if they're not assigned to an area, to continue this M2 setup messages with responses. So basically the MCE in our system aborts request messages until our central operation team says, okay, this is a new transmitter and I add it to the area. I will show you that in a minute. And as I said, once the transmitter is assigned to an area, the MCE will allow the communication. Okay, let me maybe switch to the one of our cores we run. So you see, this is also the web interface, how it looks like. You see all the entities, everything is green, which is quite nice, of course. If not, you can click, for example, on the MCE, you come to the logs, it's already filtered under the for the MCE, and you see what happens, what changes happened, and so on in the past. You can filter that and so on. As I said, if you're an expert, you can change the core settings. So you quickly go to core settings. We clustered them into global sync settings for the sync protocol, for MBMS and interfaces, and there's also something for emergency warning where you can do specific settings for that. And here you also see, as I said, everything is virtualized. You see currently which pods are running, and there's also an MBMS gateway at the moment indicating there is also a service at the moment running, which we will see probably later. So that's basically the core settings you can do. The second thing experts can do are reception settings. So as you see, we have at the moment one reception area, which is Vienna. And if I want, and we have reception conditions, as I said, so we can basically add a new label. I don't know, let's say just stationary, and make a description. Stationary reception. And we edit. So we have now two labels. And if we, for example, let's add a new area, then you can create, I don't know, Salzburg. You can, of course, do all the settings you would like to have here. Then you can set here the bandwidth, which is the resource blocks, which refers to the megahertz, for example, 5 megahertz. Then you can do settings for the MCCH and the repetition protocol. And the interesting part is basically, of course, the PMCH configuration, because here you can now select the label and you say, okay, in Salzburg, mobile means modulation coding scheme, I don't know, 9. And I will add 40% of the whole bandwidth. And you will see, okay, 40%, which means 900 kilobits per second. So if I want to add a second one, I say there's stationary, which means, I don't know, MCS 22, and allocate 50%. So you can here basically see how your multiplex or your 5 megahertz channel in this case, or 8 megahertz channel, if I change the bandwidth, will look like, and also the maximum bandwidth I can have. Then I save the changes, and I have the second MBSFN area available. Yes, so when it comes then to transmitters, so that's basically the experts. For the operation team, when it comes to transmitters, we have here the transmitter and reception areas. So you can select your reception area. Let's have a look in Vienna. At the moment, we have one transmitter running and connected to the MCE in Vienna. And as I said, we have this process. So if there is a transmitter waiting, basically polling the MCE, so we see there are two other transmitters, one Tredes, one Rubin and Schwarz transmitter. So if you want to add the Rubin and Schwarz transmitter, for example, in the Vienna reception area, we give him a speaking name, like, so IGL is one of our locations, and we edit, then it's basically added, and that's it basically to add a transmitter. And we should also see it somehow in the MCE. There was a transmitter added, and M2 connection created. Everything is fine. And from the input, I think that's the last thing I want to show you here. As I said, we have already one channel. It's an RTP channel, so you can easily stop them, delete them, or add new channels. Currently, we're supporting RTP and -HLS channels with different methods. And the interesting part, just to show you how it will work for the operator team, is if I have, I don't know, for example, channel 2, and I give it, take a multicast address and the port, then the operator just needs to select the area or Salzburg and the condition. So there's no 3GP terminology. And you also see, if you select it here, how the configuration is. So he knows, okay, for Salzburg mobile, which is here on the left side, mobile, I have 900 kilobits. So I reserve for the RTP stream, I don't know, 800, and add the stream. And that's it. And then I can start a stream here. And yeah, basically that's it. Yeah, this is how it looks like. So let me continue maybe here. From the feature perspective, I just want to announce there are a lot of yeses of all the features. Just want to say at the moment we're working also on the service announcement support. So that's not covered at the moment. And we also would like to early add the release 19 features if there are any in 3GP. From the TRICE perspective, so the idea is that 5G-MAG members can get free test licenses here. So you need to contact my colleague, Gokul. There must be a license agreement signed, and you will get the software and the license. And the test license will allow you to have basically all functionalities, with the only thing that you can have input sessions up to 15 minutes, and then it will be stopped and you need to recreate them, and one transmitter, and the license will be up to 3 months. But of course, we are flexible. So if you're interested, get in touch with us. And that's it from my side.